Hello there, this is Lana Tuckey, and I'm going to be doing a couple lecture videos here for section 7.1. We're going to be graphing quadratic functions in vertex form. So let's start with the basic parabola graph, which is f of x equals x squared. Let's see what that looks like. So we can probably fill in this table by hand. We don't need a calculator or anything for this. You're going to be inputting these x values right here into the y, or into f of x to obtain y, I should say. All right, so if I had 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Then let me just show you how this works. If you had negative 1 squared, that'd be negative 1 times negative 1, which would be 1. Right? And I could do the same thing for 2. So negative 2 squared would be negative 2 times negative 2, which would be 4. Notice when you take a negative and you square it, it turns positive, right? So I have 1, 4, 9, 16, 25. All right, so now I'm going to graph those points on this grid and connect them up with a curve. Here it is. Now the program I'm graphing in doesn't let me put little arrows at the end, but you should, right? There should be little arrows at the end of the graph here. All right, so that's a basic graph. Now let's look what happens if I start playing with the number in front of the x squared, i.e. the leading coefficient, which we learned about in section 6.1. So I have regular x squared, that has an a of 1. Then I have 2x squared, which has an a of 2, and an h of x equals 4x squared, which has an a of 4. So what do we see happening as we increase our a value? The larger that I let a be, the narrower steeper the parabola, right? So if you look at 4x squared, that's a lot steeper of a curve than the red one, which is x squared. If you were a ball rolling down one of these hills, for example, you'd roll a lot faster on 4x squared than you would on regular x squared. All right, now what happens if I make a smaller? Let's see here. So back here. So I have f of x equals x squared again. So that's the red one still that we graphed before. Then I have a half x squared and a fifth x squared. So I'm letting a be a half, so I'm letting a get smaller, and then a equals a fifth is even smaller than that. And you can see that I've color-coded all these graphs. I forgot to mention that. I color-coded them in the previous one as well. So on your paper, they might be pretty black, gray, and gray, light gray, dark gray. But here you can highlight them. When I did them in class, I used highlighters and went over all the graphs with highlighters. That would be a smart move, right? Because you got to try to keep the three graphs separate. All right, so here's x squared, the red one. There's a half x squared, the black one. And there's a fifth x squared, the blue one. So you can see as I let a get smaller, the graph is getting wider, shallower, I guess that's the word you would use. Less steep is what you're saying. It's not as steep as it used to be. All right, now what if I make them negative? All right, so again, I made the negative x squared is the red one right there. And then I have negative a half x squared is that black one right there. And then negative 2x squared is the blue one. So you can see couple things are going on. First of all, the red one here was regular x squared, and the red one down here is negative x squared, and you can see that they're reflections of each other, right? They're perfect reflections of each other across the x-axis. The x-axis acts as the mirror in this situation. I also can see it with the black one, the half x squared, and this black one, the negative a half x squared. They're mirror images of each other. All right, then there's something else going on here. If I let the absolute value, that's what those little vertical lines mean. It means absolute value. Don't worry about negative or positive. Just look at the absolute value. So if the absolute value is greater than 1, that'd be like the blue one. Absolute value of the blue one, the blue A right there is 2, right? And then the absolute value is less than 1, right? That's a half. What happens is the parabola that has an absolute value that's greater than 1 is steeper, narrower, than if the absolute value of a is less than 1. In other words, if you have a fraction in front, it's going to make it kind of a wider, fatter graph, right? shallower. And then if you have it so that absolute value of A is greater than 1, like the blue one, the 2, then that's going to make kind of a skinny, narrow, steep graph. All right, so let's summarize all of this because A has quite a bit of an effect on the graph here. So if A is greater than 0, that means if A is positive. So for example, all these graphs up here, A is positive in every one of those. A is 1, A is 2, A is 4. What happens with all these parabolas? They open upward, right? They're like arms are opening up. So they open upward. Or I can just say up. That's fine. Where A is negative, this graph has got negative. -1 for the red one, -2 for the blue one, -0.5 for the black one. So that's open down. Now, the last two bits are getting at what we were just talking about here. If A is kind of a large number, the absolute value of A, absolute value of A, because negative just means it faces downward, but this property still is going to hold. So look at this blue graph, for example. It was -2, for example, but the absolute value of it is 2, which is kind of a large number. Then the parabola is narrow, steep. Right? If the absolute value of A is a small number, like the black one here, which is 1/2, then the absolute value of that is 1/2, and that's not very steep at all. It's very wide, and it's a shallow parabola, not very steep. All right, so that's how A affects a graph. Let's see what else we can do. All right, so now we're going to look at functions of the form f of x equals x squared plus k. So we're going to start adding on a number at the back end of these graphs and seeing what happens. All right, so I have x squared, again, in red. Then I have x squared plus 5, which is the black one, and x squared plus 8, which is the blue one right there. All right, so there wasn't a really good way to label these because they're kind of tricky, but hopefully this makes sense. Okay, so we have x squared plus 5, x squared plus 8 is blue, and x squared. Now, how is k? K is that number we're adding on at the back end. How is that affecting it? Well, it's shifting the graph up, right? So if k is positive, let me write it this way, k positive, the graph shifts up. No trouble. If k is negative, which is these three, then the graph is going to shift down. So you can see you have your x squared, which is your regular red one, but then you start moving it down 4, 1, 2, 3, 4 for that one, and down 9 for the other one. So if k is negative, -4 in this particular black one, and -9 in that particular blue one, then it shifts the graph down. I should say k. It moves the graph up k. So you move it up by k numbers, like you move the graph up 5, you move the graph up 8. Here you move the graph down 4, you move the graph down 9. So if k is positive, the graph is shifted up. If k is negative, the graph is shifted down. And then the vertex is a really important point. It's the point where the axis of symmetry intersects the parabola. So it's in other words, it's the minimum for graphs that face upward like this. It's the little peak that's at the bottom. Or for ones that face downward, it's the peak that's at the top right there. And you can see that a regular parabola graph right here goes through 0, 0. That's the vertex. I'll highlight it. That's the vertex. Oops, let me do it in yellow. There we go. So the vertex is down here, the very, very tip. I guess it's the tip bottom, not the tip top, right? So the very tip bottom, right? Tip bottom right there. They're all 0, 0, all 0, 0. All of the ones up to this point were 0, 0. But now for these ones, they're not at 0, 0. They're at 0, 0 for the red one, but 0, 5 for the black one, which you can't see. There it is. And then 0, 8 for the blue one. This one's 0, -4 for this black one, and 0, -9 for this blue one. So what are we learning? We're learning that the y-coordinate of the vertex is k. We haven't dealt with the x-coordinate yet, but the y-coordinate is k. It's a point, the vertex is, so it's going to need both an x and a y. So we've got the y part figured out. We're going to figure out the x in a minute. Speaking of which, let's go figure that out. What happens if we start putting something inside the parentheses with the x? So if you make it x minus h squared. Now notice that has a minus inside it already. That's very important. It's going to make it so that everything looks backwards. So let's look at the first one. We have x minus 2 squared. That means that your h is 2. Hold on, let me type that. All right, let me put that up. So it's x minus h is the formula. So that means that h is positive 2. So note, I'll put it out here actually. It looks backwards. So looks backwards. So it looks like it's going to be negative, but it's actually positive. And that's because the formula has a negative in it. Because of that minus in there, it's going to make it look backwards than what it really is. So it's a little weird. Okay? All right, so that means h is 2, which means the graph, look at that black one. It is shifted to the right, 2. You start off with the red one as your starter one, and then you move to the right 2. So graph shifted right 2. There. So we've learned a valuable lesson. Actually, 2 valuable lessons. If h is positive, it's going to shift the graph right. H, whatever your value of h is. But h will look backwards in the formula. So it looks like it's a minus 2. That means you're actually going to the right 2 because h is positive 2. Again, h is really funky. It'll always seem opposite, and that's because of what I highlighted right up here, that the formula is always a little bit weird because it's got a minus sign inside of it, whereas the other one was a plus k, so it doesn't have a minus sign in it, so it works just like you think it's going to. But this one with the h works backwards from what you think it's going to because of that negative symbol in there. All right, so then what if it was plus? What if it looks like a plus 3? Au contraire, it looks plus 3, but that must mean that h was negative 3. It was the opposite. And again, it looks backwards from what it is. So that means that the graph shifts left 3, and you can see it. There it is. It shifted left 3. So instead of going through 0, 0 for the vertex, it now goes through negative 3, 0. Right? Which means that if h is negative, it shifts your graph left, just like you think. Positive goes to the right, negative goes to the left. The part where it looks backwards is in the function itself. I'll make a note of it right here. And actually, I'll do the same up here. Looks backward in the function. That's where it's going to look strange. Everything else is going to work just like you expect. All right, so we've learned that if the graph is, if h is positive, h greater than 0, it's going to shift the graph right. And if h is negative, it's going to shift the graph left. The x-coordinate of the vertex, you can see right here. See how it's negative 3, 0, negative, this one's negative 6. Hey, look, because h was negative 6 on that one. H is negative 3 on that one, so that's why it's at negative 3. Up here for this one, it's at 5 for that blue one. That's because h is 5 for that blue graph. So your x-coordinate is h, which means you now know your vertex. Your vertex is always hk. And that's such an important idea that I put a little box around it. Vertex is hk for sure. All right, so now we have to recoup all of that into one little table. Let me type this up. I'll be right back. Okay, here we go. If you have ax squared, where a is positive, that means the graph is going to open upward. The bigger that a is, the steeper the graph. The smaller a is, the shallower the graph. Oops, actually, that's the absolute value of a. So bigger the absolute value of a, the steeper, smaller the absolute value of a, the shallower. Absolute value because you can make graph open downward by putting a negative in front. So if it's a negative ax squared, then it opens down. If you have an added on number at the end, that's shifting it up. You subtract a number at the end, that shifts it down. And then the hardest ones, if you have h inside where it looks like x plus h squared. If it looks like that, that means h is actually negative, and that shifts the graph left. And then if it looks like x minus a number squared, that means h is actually positive, and that means that the graph shifts right. And never forget that your vertex is h, comma, k. All right, we're done with this, and I'll see you back here for the next video.